In this video, we're going to take our next attempt at trying to meet the objective of factoring trinomials in the form x squared plus bx plus c. And that's just to say that we're going to be trying to factor trinomials where there's no coefficient in front of x squared, or if anything, there's a 1 there. There's a coefficient in front of x, and there's a coefficient, there's a constant at the end. And we're going to concentrate right now on all positive signs, so we can concentrate on kind of the connection between the b and the c in this expression and the pieces of our answer. So let's first talk about factoring in general. To factor a trinomial or to factor anything is to rewrite it as a multiplication problem. So we've been spending a lot of time doing polynomial multiplication. So this would have been a polynomial multiplication question. And what we learned was either double distribution or FOIL, that to multiply 2 terms times 2 terms, you would expect to write down 4 terms at first. And then you would expect to see some like terms, especially with the amount of symmetry we see up here. You would see some like terms that might combine by the end. So this would be question for multiplication, and this would be answer for multiplication. Factoring is to take a trinomial or an expression or a number and to rewrite it as a multiplication problem. So factoring is reversing this. So it becomes really important that we start looking at the connections between the numbers, the coefficients, the constants that are in our trinomials, and then the numbers that are in these factors up top here. Because when we're handed this, we don't have a step-by-step process to come up with this. It's going to take recognition. So you really got to be on your toes. And the main thing here is you got to be thinking, you got to be noticing, you got to be trying to make connections. So let's leave this example over here to reference. What we're going to do is we're going to do the first example from section 7.2 in your textbook on page 472, where we're asked to factor x squared plus 19x plus 60. So this looks like a trinomial. It's in the form that we're talking about, where there's an x squared, maybe a 1x squared. There's a constant in front of x, and then there's a constant at the end. And we have enough experience knowing this kind of multiplication problem that it's probably a safe bet that this trinomial, if it's ever going to factor, is going to factor in a form that looks like this. So I've set up 2 sets of parentheses, each big enough to receive 2 terms. They're asking us to do it by guess and check. And to be honest, by the time we're done this video, we're hopefully really going to be tipping our hand that guessing and checking is inefficient, and there's a way to be a little bit smarter about our guesses. So let's start off. Factoring x squared plus 19x plus 60. First thing I want to notice is x squared. There's not too many ways I could break that up. I know this comes about from the first times the first, and that's where the x squared comes from. So I'm just going to safely try to split up the x and the x evenly like that. And that's going to be the beginning of my guess. Now, the end of my guess is going to be the numbers that would fill in here. And I wouldn't fill in positive 5 and negative 3, because I know that if I were to multiply that out, it would match this, not the trinomial we're factoring. But it's not like we have to completely blindly guess. What we're going to do is we're going to use this example to realize that the constant that we found in the multiplication problem, when you look back to the question, these 2 numbers are a pair of factors that multiply together to make this. So I think what we should do is we should start thinking of pairs of factors of 60 and guess at those guys in pairs. So here's the thought. 60 could result from positive 1 times positive 60. So let's try using that pair of factors, positive 1 and positive 60, as our guess. So we have positive x plus 1 and x plus 60, and the only way to see whether this is the true factorization of this is to multiply it out, is to check. So the check then is going to be a process of FOIL. The check then is going to start off with 4 terms, and you can see our x squared. That's a great sign. You get 60x. I'm not going to give up on it yet. You get 1 more x from your inner, and then you get your 60. The 60 is good. And we kind of knew we were going to get 60 anyway, because we thought of factors of 60, so we're not too surprised that when we multiply it. We kind of felt like the x squared and the 60, that was going to be taken care of. But the 60x plus x turns into 61x, and that doesn't match the 19x that we were trying to factor. So it feels like our first guess didn't work out for us, mainly because 60x plus x wasn't 19x. Everything else was great. Choosing factors of 60 was a great idea. Breaking up x squared as x and x, great idea. We just guessed at the wrong pair of factors of 60. So what we'll do is we'll take that off the list, and then we'll think about our next pair of factors for 60. And before we move off of the ones, understand that 60 could be found by doing negative 1 times negative 60, because a negative times a negative is a positive. So maybe we should think about that as a guess. It's as good a guess as any, until we look a little bit closer. If we FOIL this out, we would get our x squared. We knew that was going to happen. We get a negative 60x and a negative 1x, and we get a positive 60. Again, very happy about the 60, very happy about the x squared. This negative 60x minus x, if it matches this, we're good. But, I mean, I'm seeing a bunch of negatives there. I can't imagine it's going to work out. It didn't work out. Negative 61x and 19x don't match, so we didn't find a good factorization. And again, that mainly was because the negative 60x minus x did not match our 19x. Everything else was good. Let's start getting efficient now. Because what we can do then is we can almost project. If you do think about 60 as 2 times 30, that's another pair of factors that we could guess at. But let's not go through this whole process of guessing a whole FOIL problem, checking a whole FOIL problem, because really what it's hinging on is whether our x terms, our 60x and our x, or our negative 60x and our x, whether they're going to work. So the 30x and the 2x that we were about to make, if we did check it, that's not going to make 19x. So these two guys not adding to 19 is telling me ahead of time that my middle terms are going to fail, just like the first two guesses. Well, let's think about other ways you can make 60. 60 is 3 times 20. So is a positive 3x plus a positive 20x going to get us our 19x? It's not. What's next? 4 goes into 60, 15 times. And now I'm starting to feel pretty good about this, because the 4 times 15 that makes 60 is also going to satisfy something important. We're going to get 15x when we put the 15 there, a 4x when we put the 4x there, and 15x plus 4x does match 19x. We're very happy to see that. So what we've done then is we have found the correct way to break up 60 to not only satisfy the 60, not only satisfy the x squared, but also satisfy the 19. And what it comes down to is we needed 2 numbers that multiplied to 60, but also add to 19. And you're going to hear that phrase over and over again. Once you find those numbers, now you've factored. So this expression here in the circle is our answer. It's what we got when we factored x squared minus 19x plus 60. We rewrote the trinomial as a multiplication problem. The next video is going to really kind of cut out this guessing and checking thing, and we're really going to focus on how could we be efficient, how could we be organized about finding factors of 60, and before we do too much work with them, figuring out if they're going to match our middle term.